right, so in all seriousness, let's talk about what Docker is. Docker is a way that allows you to run this thing that's called a container. All right, now I want you to think of a container as just a piece of software. So think of it as something like Microsoft Word or Google Chrome or any application that you run on your computer. Docker containers are the same way. And I'm going to do this a lot. I'm going to say Docker containers, but really Docker is only one of many ways to run containers. So containers give us a way to package our applications into a piece of software, and this makes them portable. And the reason we want them portable is because it allows us to take that portable application and run it wherever we need to run it. So doing so, it's going to run the same way because it's all packaged, okay? So think of it this way. You'll be able to build an application, package it to run as a container, and then you can run that container on your desktop, or you can run it in Kubernetes, or you can run it in Amazon Fargate or Google Kubernetes engine. You know, you can run it all of those different places, and it's going to run the exact same way because it's just a single packaged application. Now, the problem that this solves is managing dependencies and a lot of configuration for running in different environments. Let's take a typical example of running, let's say, a Node.js application on different environments. So you're going to run it on your desktop because that's where you're initially writing the code. So you've got to have Node.js installed there and all of the dependencies and packages that you use on Node.js installed there. And then you deploy it to your staging environment. And let's say your staging environment is a dedicated Linux server. So now you've got to install Node.js there, install all your package dependencies there, configure everything there. We sign off on it there. So now we're ready to move it into production. And let's say that production is running in Kubernetes. So now you've got to go and do the same thing. Actually, that's a bad example because Kubernetes can't do anything but containers. So let's say that it was another server out in AWS or whatever. So again, you're doing the same thing. You've got to install Node.js, you've got to install the dependencies, configure it, and blah, 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 blah. And so each time you go through those steps, you're introducing more opportunities to create a mistake, to either install a different version of Node.js or not configure one of the dependencies correctly or different things like that. So it introduces potentials for error so that the code that you wrote and tested on your desktop is now not working out in production the way that you built it to run.
Now, in order to understand like really the problem that Docker solves and containers solve and why it's important to us, I think it's helpful to go back and have like a little bit of a history lesson here. So if you're not interested in that, I do have chapters down below so you can skip ahead, but I really want to encourage you to listen to this part because one of the things that I've seen over and over in my long career of doing this is people who struggle or go out and invent things that have already been invented in our industry. So some of the things you'll see is someone who spends a lot of time and effort trying to invent a problem that was solved 30 years ago in Linux. And so that's what I'm hoping to derail by this little section of the video. So let's do this. So back in the day, you were going to install your software, right? So you had this physical server that you wanted to install it on, okay? But you've got to get the physical server. So the first step in that process was contacting the finance team and saying, hey dudes, can we have some money? We want to buy a server, right? And then they're going to give you give you some hassle and make you jump through a bunch of hoops before they give you the money. But then there's also the question of your manager saying, well, what size server do you need? How many people are going to be accessing this server? How much memory do you need? How much CPU do you need? And if it's a new application, the real answer is, I have no idea. So you make a guess. You say, oh, I need a server with 16 gig of RAM, and 4 CPUs or whatever. And you hope and you pray that you were right. All right, so let's say that you were right. You get that server in, you go out and you install it in the data center, you hook the power up to it, you install the cables into it, you provision it on the network, you install the operating system, you patch the operating system, and now we're ready to install our Node.js application on it. So we do that. And then we install our package.json dependencies and we configure this thing. It's probably got to be configured behind a load balancer. Got to involve the network team so they can open up the port, configure DNS, and blah, 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 right? So finally we get all of that done and our users start coming in, or our customers start coming in and accessing this server. And it turns out you did a really good job of writing the software, or if you're the sysadmin, the software development team did a really good job of writing the software and you did a really good job of provisioning, installing, and maintaining the server. As a matter of fact, you did such a great job that the customers are just growing by leaps and bounds. So you're getting all of these customers on your server, a lot more customers than you ever expected, and more customers than this server can handle. So what's the story there? We need another server, right? So we're going back to finance saying, hey, we need more money. And they're going to say, well, what did you do with the money we just gave you? And you go through the hoops and the processes again of getting the server, installing the operating system, carrying it down to the cold ass data center, packing it through there, running cables, all of this stuff over and over again, right? That's the way it used to be. So then we realized something. We came to understand that a server was really nothing more than some memory and CPU and disk space and some other things like that, right? And all of these things can be represented as software, right? Because memory is just memory. It's just an address block, a chunk of space that you can refer to by addresses. And so the long story short here is we came up with this concept of a virtual machine, or VM for short. And with a virtual machine, or VM, we came to understand that instead of using these servers over here to actually run our Node.js application, we could use these servers to run virtual computers, right? So from our perspective, a virtual computer looked just like a physical computer, except it didn't really exist. It only existed in the operating system, or in the operating space of the computer that was hosting it. Now, this gave us some additional capabilities, all right? So then we could buy fewer, larger servers. So instead of buying one server with 16 gigabytes of memory and 4 CPUs to handle my one application, I could buy a server that had 64 gigabytes of RAM and 16 CPUs and use that to create multiple virtual machines. So that was better because then we could use our hardware more efficiently. And whenever we needed a new virtual machine, it was a process of just installing the software for that virtual machine and creating that virtual server. Now, we still had to install the operating system. We still had to install the patches. We still had to install Node.js and configure it and all of that kind of stuff. But it was better than what it was. Now, the installation of the virtual machine was not the only problem. There was also the ongoing maintenance of this thing too. Every time a security patch came out for the operating system that was running on that virtual machine, it had to be updated on that virtual machine. And it had to be operated on every virtual machine that was running in our environment, right? So if we had 15 virtual machines, that was 15 servers that we actually had to patch. Now, somewhere along the way, someone really smart realized, hey, look, check this out. I've got an operating system running here. I've got the exact same operating system running here, and the same operating system here, and the same operating system here. What if we could install one operating system here and then have these containers, for lack of a better term, that ran on top of it that could just use this operating system down below, right? And that's where we really got to the container operation of things. So a container only has the things that are unique to that container installed in it, right? The default stuff that every computer on the face of the earth has, whether that's a networking interface, an operating system, shared libraries, blah, 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 blah. It just gets all of that stuff from the operating system down below. And so through that shared resource model, it really simplifies what it takes to build, package, and run applications. So now that you have a little bit of a better understanding of what Docker is and what containers are, let's talk about where you actually use that in the real world. All right. So the first place is going to be on your local desktop. That's going to be the starting point where you run almost all your Docker containers, because you're going to run, build, and test it there before you actually deploy it, right? You're going to use, most likely, the Docker desktop application to do that. And so you can download and install this from Docker. It's free to start with. There's paid versions if you want additional features and additional support, but you can get started and do almost everything that you need to do for free with the Docker desktop free version. All right, so now you're going to build it locally and then you're ready to deploy it. And there's tons of places that you can deploy it to. One of the common ones that you'll hear, if you haven't heard of it already, is Kubernetes. And Kubernetes, which we'll go into in great detail in a future video, is a way for you to orchestrate all of these containers out in production. Now, there's a bunch of different flavors of this, and maybe flavors isn't the right word, but there's a bunch of different ways to do Kubernetes, and we're going to look at those. This one here, you can download and install and run Kubernetes on your own hardware with no intervention or support from anyone at all. The other thing that you can do, and I really like this one, is a product from Amazon or AWS called Fargate. Fargate combines Kubernetes style deployments with the serverless architecture, right? So basically what that means is it allows you to run containers that you build without having to worry about the underlying servers that are underneath it. If you're familiar with AWS Lambda, same thing. It allows you to run your code without managing a server. Fargate allows you to run containers without managing the server, and it works really well. I've used it a lot. The other thing that you can do if you want to stay within Amazon is use the Elastic Kubernetes Service, or EKS. With EKS, there are EC2 instances underneath it that you pay for and that you use, but you get the full Kubernetes environment. So you still have all of your Kubernetes commands, and everything that you can do in Kubernetes, you can do in EKS, but you don't have to worry about the day-to-day administration of that underlying Kubernetes system. Same product offering exists from Google in the Google Kubernetes Engine, or GKE. And then likewise, if you're over in Azure from Microsoft, they have the AKS, or Azure Kubernetes Service. Now, in addition to that, you're also left with the option of building, installing your own hardware and just running Docker or some of the other container solutions like Containerd, just directly managed by yourself. That is one option. Although with the way that Kubernetes has, progressed and the amount of documentation and support available for it, I would be interested to hear about any reasons why you feel that you should run Docker directly on your server instead of something like Kubernetes. I mean, there's probably a good use case for it. I just can't think of one. All right, cool story, bro, right? So all great stuff, but what do we actually do with Docker? Well, let's take a look at some of the common commands that you're going to use whenever you're using Docker. So one of the common ones that you'll use is Docker images, and this shows you a list of all of the images that are installed on your local computer. You get the name of the repository that it came from, the tag, which we'll get into tagging here in just a minute, the image ID, and when that was created. Another command that's really handy is Docker PS, and Docker PS shows you the Docker containers that are currently running on your system. So that's an important distinction there, right? We had Docker images, which showed us the Docker images that were downloaded onto my computer, but a Docker image is not a running instance. That's just like a downloaded application. It's like downloading Google Chrome, but then Docker PS is actually showing me when I launch and run Chrome. So it's the difference between the file existing on your hard drive and the file running within the Docker engine. So I showed you the Docker images that I have on my computer, and you might be going, well, that's cool. How do I get one? So you use the docker pull command. So I can say docker pull nginx latest. And that's going to actually pull the nginx Docker image from a place called the Docker Hub. So the Docker Hub is Docker's official repository for storing images. And so you can search for anything here that you're looking for. If you're looking for nginx, or if you're looking for databases like MySQL or Postgres or MongoDB or other web servers like Apache, pretty much everything that you're going to want to find is available here on Docker Hub. Now you can also have your own private repositories, which we will also get into here later on in this video. We've downloaded the nginx image and I want to run it. So how do we actually do that? We want to make it do something. So we do that with the run command. So we do docker run and then the name of our image and the tag, which again, I'll get to tags here in just a few minutes. And so there we go. We just launched our first container using the nginx image, but it's nginx, right? So ideally this should be serving up a web server, but it's actually not. So how do we do that? Now, if you know anything about web servers at all, you know that web servers publish a specific port, most often port 80 or port 443 for SSL traffic. But in Docker world, whenever we launch a container, it doesn't expose anything by default. So we have to tell it what we want to expose. Now there's a specific flag for doing that, but you may not remember what that is. So it's better if I show you how to find out where that is in the documents so that you can find it and other flags for yourself. So we're going to go to docs.docker.com and we're going to go to the reference section. Now we're specifically working with the Docker command. So we're going to go check out the reference docs for the Docker CLI. And then we were running Docker run, right? So scroll down here. And if I remember my alphabet correctly, here is Docker run. And now on this page, we've got a list of all the options that are available for the Docker run command. I happen to know in this instance that I want to expose a particular port. And I know that that's the -p flag. And to be honest, I actually always thought that the -p stood for -port, but it appears that stands for publish. So either way, it does confirm here that -p will publish a container's port to the host. So let's clear that off the screen. If we go back to our terminal here, we're going to do -p and we're going to expose port 80 on the container. And I'm going to expose that as port 8888 locally for me. So let's jump back over to our container here. And we're going to do a docker run nginx latest. And so our flag actually has to come here between the docker run and the nginx, or the name of the image that we're running. So we're going to expose port 80, and I'm going to expose that on port 8888 locally. So that's up and running. So in theory, if I open a new tab on my browser and I go to localhost port 8888, oh, denied. Did I do that wrong? Well, clearly I did do it wrong. Oh yeah. Okay, so what I did here is I went back to Docker Hub, looked at the image that we were using here, and when you scroll down, there's info on how to use that as well. And in this case, I got the parameters backwards on my Docker command. So let's kill this, clear the screen, and I actually want to do my port first, followed by the port on the container. So let's try this again, and welcome to nginx. All right, good times, right? So now if we go back over to the terminal window here, you can see that nginx is logging out the access logs to the terminal here, but my terminal is also kind of tied up at this point. I can't really do anything else with this. So let's make that better, right? I'm going to kill that. Let's clear the screen and we'll run the same command again, but this time I'm going to add the -d flag on the end of it. Now the D stands for daemonize, and what that's going to do is throw an error because again, you got to throw your flags up in front of the image name, and you would think after, I don't know, 200,000-300,000 times I would remember that, but I don't. Run it again, and now look at what happened. It just threw out, I don't know, looks like some random characters there, and returned me back to my prompt. But, you know, I've got my terminal back now, so that's cool. And I can refresh my page here. So it seems like Nginx is still running, but we feel kind of like we're in the dark right now, right? So let's see what we can do about that. Let's go back over to our terminal here, and I'm going to show you a command called Dockerps, and that's pretty worthless, right? So I'm going to actually combine Dockerps with a grep for Nginx. Actually, let's clear the screen so it's legible. Do that command again. And so here is our Nginx container that we launched. We used the -d flag, so we daemonized it, which means it launched it in the background, so it's still running. It's just not tying up our terminal. Yet here it is. We can find it with our Dockerps command. One of the things you'll notice that I got kind of a weird screen wrap going here, trying to keep the font big enough for you to see it. But whenever we launched it, Docker gave it a name. It gave it the name Loving Golic. I don't know what that's supposed to mean, but we're just going to ignore how weird of a name that is and just be happy that we got a name. All right, so now what we can do is we can do Docker logs and type out Loving Golic, because, yeah, whatever. I'll keep that to myself. Yeah, so here are our access logs. Let's clear the screen again. And if I do Docker logs -f, it's going to follow my logs. So I'm going to go over here and just refresh the page a bunch of times. And it's just spewing out the logs here. Whenever I'm tired of looking at the logs, I can Control-C and get out of there and go back to my terminal. All right, so far so good, right? We downloaded an image, we launched it, we exposed ports on it, we learned how to run it in the background, and we saw how to capture the logs from it. But what if I actually need to get inside of that container and poke around a little bit? It happens, right? Sometimes you just need to see what's going on in there and take a look. One of the places I commonly do this is whenever my CI/CD system is supposed to attach config files or generate config files for my application. But when the application launches, I get this sneaking suspicion that one of the config files either isn't there or has an invalid value. And I just want to take a look and see. I don't want to do anything. I don't want to make any changes. So we can do this. What was the name of that thing again? Oh yeah, Loving Golic. So if we type docker exec-it, which IT, I'm pretty sure stands for interactive terminal, although I screwed up the -p earlier, but we're going to stick with IT because interactive terminal is something you can remember. Docker exec-it, Loving Golic. God, I should just redo this video just to get rid of that name. And so now the exec with IT is going to ask me for a command that I want to run. So we're saying Docker execute with an interactive terminal on Loving Golic this command. Now I like bash. I've been using bash for decades. I'm kind of stuck on it. Probably not going to change, but not all Docker images have bash. This one does. If it doesn't have bash, one of the things that's almost always guaranteed to work is just sh, and that will run the standard Unix shell, although that's pretty limited in its features. But anyway, going back into bash, now here you can see that I am logged in as root of this image, and I can do an ls. You know, I can poke around the file system, like if I had a file, if I had my config files stored somewhere here, I could use the cat command and just cat that out to take a look at it. Now, most of your Docker images are not going to have a very full-featured suite of tools on them. So you're probably not going to have things like Vim or Nmap or different things like that. So you got to kind of rely on just the bare minimum, which is okay because we don't really want those installed on there, because every package that we install in our Docker container becomes a dependency for us. It's something that we have to maintain, we have to update, we have to watch for security vulnerabilities and patches and all that kind of stuff. So the less that we keep in our container, the more robust, reliable, and maintenance-free it's gonna be. All right, so let me show you this, because I just showed you how to access a running container, and I mentioned that one of the common reasons I do that was because config files get messed up, or, you know, let's be honest here, they don't get messed up. I don't apply them correctly, right? I got to take accountability for that. But how do we change that, right? Let's do this. We're going to go back into our Docker container here, do an ls, and let's just do echo hi will into will.txt. All right. So if we do our ls command again, right here is will.txt. Let's assume that will.txt is a config file, and I just created it to make it all work, and now my website is up and working as expected. All right. Now let's say that my my website dies, and we can simulate death with docker kill loving go lick. So now if I do docker exec, or no, I don't, docker ps pipe grep nginx, there's nothing running. And if I try to refresh the page, it can't connect to it. All right, so that's cool. We've confirmed that it's down. So now let's start it back up with docker start loving go lick. And so we should be able to get back into it with docker exec -it. And if we do an ls, we've still got our will.txt file over here, and we can actually cat that fat thing out, and we get it there. But here's the deal. That name is really bothering me. It's just killing me. So we're going to docker kill loving go lick forever. And we're going to do a docker run -p 888 to port 80. And we're going to do -n for a name. And we're going to call it web server. Then we'll give it the name of our Docker image, which is nginx with the tag latest. And let's daemonize that too, so it's not tying up my terminal. God damn it. Oh, my bad. It's not -n. You got to do the whole thing. So it's --name. So now if we do docker ps pipe grep and we look for web server, it's up and running. And now here's what I wanted to show you on this. We'll do our docker exec it for web server with bash. And now look at this, the will.txt file is gone. And here, that's the point that I wanted to make on all of this. Like, never, ever, 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 ever go in and change stuff directly on your Docker container, on your running Docker container, because it's not persisted anywhere, right? Now, it was persisted in that one specific individual container, but we can't guarantee that that container is going to be around forever, right? It's going to die at some point. And also our application is going to scale up. It's going to scale down. We're going to do future deployments and all that kind of stuff. So those changes will ultimately be lost in that container. So never make changes to your container. Make changes when you're actually building the Docker image, and bake those changes into the image itself, which we're going to get into that here in the next section. All right, so now assuming that you never need to do anything other than launch a Docker image from a publicly available repo, and you don't need to modify or customize that at all, you kind of know everything that you need to know about Docker. But let's say that there's the offhand scenario where the website you launch using a Docker container needs to display something besides welcome to Nginx. Well, that could happen, right? So how do we do that? The way we do that is we're going to build our own Docker image. And we do that with something called a Dockerfile. Now, as you might have guessed, a Dockerfile is a file. It's just a text file that contains a set of commands and instructions that tell Docker how to build your Docker image. All right, so let's go ahead and create a new file here. And we're actually going to name this Dockerfile, which is the common naming convention for Docker files. If you have multiple Docker files, what I tend to do is give it like some descriptive name and then give it the suffix of Dockerfile. And a lot of systems that you'll use will recognize that as well. But since this is our only one, we'll just call it Dockerfile. And now the very first thing that goes into a Dockerfile is where you're getting your base image from, right? So it's very often that you'll use the image that someone else has built to start building your own Dockerfile, right? And that's kind of important. Actually, it's more than kind of important. It's super important to know where you're getting your Docker image from, right? Because this is the base. This is what we're going to be building on top of. So everything that's built into that Docker image is going to be available to us in our Docker image. So where you get your Docker images from or your base images from is super, super important. Let me explain why. So as I said, everything that's in that Docker image that you're using as your base image is available in yours. So if I build a base image and call it, Nginx, but I include a Bitcoin miner in there, when you use my base image, you're getting my Bitcoin miner and it's probably going to run. And so you're going to be mining Bitcoin on my behalf. Thank you very much. Great for me, not so great for you, right? So for that reason, you want to be careful where you get your Docker images from. You don't want to get them from like Billy Bob's bait shop and Bitcoin mining. You want to use something like the Docker Hub, and even the ones that you get from the Docker Hub, see what's in them, see where they get their images from, and do your homework to trace this back down so you know exactly what you're getting, because anyone can create an account on Docker Hub and anyone can publish an image there. So just because it's on Docker Hub doesn't mean it's safe. They scan and monitor, and they do their best, but ultimately the burden of proof falls on you as the consumer. So now when it comes to customizing a Docker image that you're going to use as your base, the documentation for that image is your best place to start, right? And there's a quick reference right here that gives you some info, but then just down below, you almost always find how to use this image. So we're going to start with this. We're going to copy our own files into the Docker image, our own website. So we'll create a folder called HTML and we'll create a file in there, index.html. That's going to get open for editing, and we're going to go super complex. All right, that's our HTML file. That's badass, right? So now we'll use our Docker copy command, and we'll copy the HTML folder over into user share Nginx HTML of that image. So now I think that's all we need to do. Let's try it and see. We'll do Docker build. We'll give it the -t to tag that. We're going to tag it with a name called web server and a tag of latest. And then we'll give it just a single dot, and it knows to look inside the Docker file or inside the current directory for a file named Dockerfile. That completed successfully. So now if we do Docker images, and then we'll grep for our image name web server, sure enough, there it is. So if I did this right, we should be able to do Docker run, expose our port 8888, mapped back to port 80. And then we won't daemonize it this time, but we will give it web server latest as the name. It seems to be started. And if we come over here and refresh, there's our super stellar, amazing, highly formatted, professional website from DevOps for developers. So that was pretty simplistic, right? I mean, it was kind of easy, but there's a lot more we can do. If we go back to our Docker docs, our Docker docs, we can go back to the reference documentation and we can see the reference file for the Dockerfile file format. Now there's a ton of stuff in here. So we used the copy command to copy a directory into our image. So you have an entry point also available in your Dockerfile. And this is like the thing to execute when Docker launches your image and runs it as a container. You also have one called command, CMD, which is more frequently used. Now, I think part of the reason behind that is because you can have multiple entry points defined, but you can only have one command. And so by using the command instruction, you kind of just eliminate the possibility of having the wrong thing or inadvertently setting up the wrong thing to run. Having said that, though, I believe an entry point will override a command. TLDR, I just use command. So the way that command works is it's an array of commands and parameters. So you'll just create this, and for each line in your startup command, you'll add that as a separate item to your command array here. Great example here for using the Linux word count command. So we want to run the word count command located at user bin wc, and then we want to supply the argument to it --help. And so we put those in as two separate elements of the command array. Hope that makes sense. Expose is another argument or another thing that you'll commonly have in your Docker file. And this tells Docker that it should be listening on a given port. So for example, in our Nginx example, Nginx is listening on port 80, right? So if we look at the Docker file from Nginx on that, there's going to be an expose command telling it to expose port 80. Now, expose does not publish the port because we still had to use the -p flag when we launched our container, right? It's a combination thing. Expose tells Docker to open that port up in the container. P, whenever you launch it, tells Docker to connect to that exposed port. Now, there's a ton of other commands and arguments that we can use inside of our Docker file here. I'm not going to go through all of them. I'm not even going to go through any more of them because the documentation, I think, is really, really well defined here. So when you have a particular need, you can look it up here and you can see how it's used, and they generally have really good examples for how to incorporate it and some description on what it's for. But in my experience, the most common things that you have in your Docker file are the command telling it, obviously, hey, launch this application when this container starts. Copy, you'll copy stuff into your Docker file or into your Docker image. Exposing different TCP and UDP ports that are used or made available by your application. And then one of the other common ones, let me show you this one real quick. Now here we go, run. So run actually comes out to be pretty frequently used by me. And so what that's saying is run this command inside of the Docker image. Let me give you an example of that. So inside our Docker container here, we could give it run, and let's say something like that. So just it executes a command inside the image while it's building the image. So the end result of this, whenever you launch your container, would be nothing. But during the building of the image, when you build that image, it's going to run this command and create that file will.txt with the contents hi will. And then whenever that container gets run, whenever that Yeah, whenever that image gets run as a container, you would actually be able to look in the root directory and see that this file already existed because it was created when the image was built. Now, another really important concept in building Dockerfiles is the concept of multi-stage builds. So what I mean by that is for a lot of applications, you run this build process, or you take your code from your repository and you download it, and then you have to compile it or build it or transpile it or something like that to create the finished product that works out on your production applications. But when you deploy that out there, you don't want to drag along all the source code with you, right? That just creates larger Docker files. And it also opens up security vulnerabilities where if someone were able to exploit that production Docker image, they could not only get your production application, but they could get the code that you use to build it, which may give them more insights into how to hack your system or use that against you. So in general, you don't want anything running out in production that's not needed for production. So let me show you what that actually looks like. I've got an example here. So you can see we start off with a from command again, just like we did in the last example. This time we're using node 14.15.0 Alpine release. And then we've got this as command here calling it as builder, right? So I've named this image builder. So what we're doing here is we're going to build an intermediate image. It has the name builder. And then I set a couple of arguments here that are used by the build process. Those will be passed on the command line to the Docker build command. And then we have a run statement here, like I showed you in the last example. This time we're running a command called apk, which for the Alpine Linux distribution is the package manager. And we're running an update to get the latest updates. And then we're running an upgrade to install the latest packages available. And then we're doing an apk add to install bash, make, git, Python 3, and curl. Now, a lot of those are needed for the build process, but they aren't needed by my application once it's built. We're setting a working directory here called /app or app. Now, the nice thing about the working directory command is it will create that directory for you automatically. And then on line 9 here, what I'm doing is I'm updating my path environment variable to include the node modules directory, the bin folder within that, so that whenever I type a command that's installed by my node packages, it's available on my path. So in the project repository where this gets built from, there's a folder called client, and we're just going to copy it into the working directory here, which is app. And then we're going to run our command npm install, which is going to install all of the dependencies required by my application. The final thing we do here is we actually build the application, and we do that with the npm run build command. And so what that does is it takes the TypeScript and JavaScript in this application, and it creates a JavaScript bundle and an HTML file that can be used as my application. Now, the end result of this is an index file, an HTML file, and some JavaScript files. And everything else we've done prior to line 14 here is no longer needed, which is why I did this as a multi-stage build. So then you'll see on line 16 here, I jump down and I get an image from Bitnami Nginx latest. And now that's kind of an interesting side note there. In our previous Docker file, we just pulled Nginx latest from Nginx on the Docker Hub. This time I'm specifying I want the Nginx image built by a company called Bitnami. Now, whenever you're building Docker images, and later in future videos, whenever we get into talking about Kubernetes and using Helm charts, I use Bitnami a lot because they are just rock solid and they develop quality products that are really, really well documented. And so we'll get into that in a future video, which is a great hashtag shameless self-promotion. If you're not a subscriber to the channel, be sure you subscribe so that you get notified whenever I release those videos. Line 18, jumping down, creating our working directory again. Now we did that in line 7, right? But that was a completely different Docker image. That was our builder Docker image. Now we're working on a new image. So we've got to recreate that. And then I'm copying some files over in my repository. There's a deploy folder with an Nginx config file. That's some configuration on how I want Nginx to be configured and to execute. And so I'll copy that into the config file location for my Nginx image here. And then the last thing, we're doing another copy. This time I've got the from --from argument where I specify builder. So that's saying, hey, dude, from that image that you just built right up there, go ahead and grab everything in the app build folder and copy it right here. So that's an example of a multi-stage build. And again, the reason that we do that is because I did a lot of stuff to build that bundled application, and I didn't want those artifacts living out on my production Docker container. So I was able to build them and then just copy the end result of that build process into a new fresh image, which made sure that those artifacts aren't drug along with me. And then also, every time you execute a command or a statement in a Docker file, it adds to the size of that Docker file. By doing that in an intermediate build image, then all of that stuff was just discarded and doesn't contribute to the overall file size of my Docker image, making sure that I have nice, tight, concise, performant Docker images. All right, so the last thing I want to talk about in context of Docker files are rootless containers. Now, if you've used Linux or Unix at all in the past or are very familiar with it, you know that there's this user called root, R-O-O-T. And so root is the system super user. Like root can never be told no. If you're familiar with Windows, root is like the equivalent of the administrator, but not like the Windows administrator where you say right-click run as administrator and then you try to do something and it says, oh no, you got to be the administrator or whatever that Windows thing is that it does. Now, it doesn't work like that in Linux. Like root is root. Root never gets told no. And so by default, your Docker containers will run as root, which is bad. The reason it's bad is because root never gets told no. So it opens up the possibility for someone to get an exploit working against your Docker container. And then once they have that exploit working, they're operating inside your container as root. So they have all privileges, and it just gives them more opportunities to do malicious things. So we actually want to run our containers as a user other than root or as a non-privileged user so that whenever we do get attacked and they are able to exploit our images, they really have a limited set of permissions, and we've limited the number of things that they can do to cause harm. All right. So now in our Nginx image that we've been working with, you might have noticed that we were working with a Docker image that exposed port 80 for our web server, which is okay. All right. That's the traditional web port for HTTP traffic. However, if you know anything about Linux, you know that only root can open port 80. All ports below 1024, all TCP ports below 1024 on Linux operating systems are called privileged ports, and you have to be root in order to open those ports up. So even if you didn't know anything else about this Docker image that we're using, once you saw that port 80 was open, you knew that we had to be running as root. And so let's not do that. So I'm going to go back to the documentation for our Nginx image here. And documentation for any good Docker image is going to include instructions on how to run as a non-root user. So look at that. There's a section here, running Nginx as a non-root user. It says it is possible. Here's what you got to do. And then we have to redefine this, and then we have to update some HTTP context. Oh, look, or alternatively, we can check out the official Docker Nginx unprivileged image. And so if we want to use that, click on that link, the page opens up, and here's some details. The listen port is now 8080 instead of 80, right? That's good. The default user directive has been removed. The default Nginx PID has been moved from var run to temp, and then some temp path variable changes So all of that's good, right? That all means that we're running as a non-root user. And to implement this, the only thing we have to do is change the from command in our Docker file to say, instead of pulling from nginx latest, we're going to use nginx inc / nginx unprivileged. So let's do that. If we change this here, we'll just go nginx inc / nginx unprivileged. If I can spell privilege, is that right? I don't know if that's right. And then we should specify a tag, and I'm going to put latest here, but keep watching the video because I'm going to explain not only what tags are when you talk about Docker images, but also why you never want to use latest. So we'll be back to change this here in a bit. So let's take a step back here for a minute. In the last section of the video, we copied some HTML content, a super stellar badass website, I might mention, into our Docker image and built that as our image. But if we think that through, like that means every time we want to make a change to the HTML on our website, we have to rebuild our Docker image. And that means if we want to change like the HTML itself, or if we want to just replace an image, or if we want to update some text because there was a typo, actually going back to the whole image thing, like if our website has a bunch of images on it, each and every single one of those images is going to have to be baked into our Docker container or our Docker image. It seems pretty horrible, right? There's actually a better way to do that. And that's where Docker volumes come in. So with Docker volumes, we can actually mount a volume as a mounted container or as a volume mount inside of the container. Let me show you what I mean. So originally we started with this command, docker run. We published our port 8888 to port 80, which was exposed by our Docker image. And I know we talked about using the unprivileged container, but I want to stick with this one just so that we're only changing one thing at a time, right? And that launched the default nginx image. Now we can also do this. We can do -v. And so we're going to mount users will button, code will button, HTML. So we're going to give the full path of the thing we want to mount. And then where we want to mount it is user share nginx HTML, and then another colon and RO for read only. So we told it, hey, get everything in this path, mount it at this location with these permissions. Let's see if I did that right. Yeah, so far so good. I mean, it didn't like blow up immediately, right? So we switch over here and we refresh. Look at that. Hello from DevOps for developers. You don't believe me, right? Fine. Let's go take a look over here and see. Let me open a new tab. Crank up the font. See what we're running here. We're running Clever Bows this time. At least that's a better name. We'll do docker exec-it for interactive terminal. And then we want that to run on Clever Bows. And we want to run bash. And so we mounted that on user share nginx. Easy for me to say. HTML, right? So if we do an ls, there's index.html. If we cat that out, there it is, our wonderful website as seen from within the Docker container. And we didn't do anything other than launch the vanilla nginx image, right? So we didn't have to make any changes to it. And what that means for us in this specific example is every time we want to update our website, the only thing we have to do is update the file contents on that mounted volume. We don't have to do anything with the running Docker container. We just change the file contents, and the next time Nginx hits that particular page, it will reload with those changes. Now, when we do that, you can do just like I did here, where that was a volume mounted from a file on this system. You can also mount something like NFS, a network file system, from a Linux or a Unix file server. You can mount CIFS or Samba shares from a Windows file server. If you're running out in Amazon, you can use EFS, the Elastic File System, or you can use persistent volumes and persistent volume claims if you're using Kubernetes. And if you don't know what any of those are, we're going to have videos about all of those here coming out in the future. So that's a great reason for you to subscribe to the channel so that you don't miss out on that content. All right, so if you've been following along so far, we've been using a single Docker container or Docker image to launch a single container. And I don't know about you, but I have never been in a scenario where I only had to launch one thing for an application. You know, there's always databases and caching servers and multiple instances, you know, for high availability and redundancy and blah, 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 blah. Not to mention the fact that our Docker command is getting pretty gnarly, right? It's Docker run -p and some numbers, and then -v because we got to mount a volume to it, and then a -d because we want to daemonize it, and -n because we don't like the stupid names that it comes up with, and then we got to remember which Docker image that we're launching from, right? That's getting pretty nasty. So if we do that for our website, plus the database that we need, and if we need an Elasticsearch server to go with it and a caching server, like that's a lot of really nasty commands, right? And nobody wants to do that. Well, fortunately, we don't have to. There's this thing called Docker Compose. Now, what Docker Compose does is it's a lot like a Dockerfile. A Dockerfile specifies how to build your image. A Docker Compose file tells you how to run and architect all of your images. Let me show you what one looks like. All right, so now this particular application, I switched applications on you in the background. We've got a Node.js server that's using Express.js to work as an API server. We've got a database we're running Elasticsearch, right? So if we take a look at the top, right here on line 2, we're defining our services. This tells Docker, the Docker Compose command, what services it's going to be launching. And this is just a YAML file, right? So the very first server is named Express. And if you look below that, the container name is also going to be Express. So we don't have to worry about some random container names that Docker is going to try and generate for us. We've got a build argument here. Now this is like our Docker build command. And then the context of a single dot says, hey, do it right here, this directory. Don't go looking anywhere else. It's right here. And we even specify the Docker file. In this case, the Docker file happens to be named Dockerfile. But if you remember earlier in the video, I mentioned how that may not be the case. And this allows you to specify when that is. We've also got our volumes here where we can mount some different volumes. Now we're mounting the dot slash tells it mount the current directory. We've got the colon, which is our separator, and then /app, which basically tells it mount this volume, the current directory right here where you are, mount that inside the container in a folder called app. And now we're also mounting app/node modules. Now, the reason that I'm doing that is because if you're familiar with Node.js, you have this node modules things, which is the installation of all of the different dependencies your application depends on. So when I'm building here locally, and you'll see how this works, so stick with me. When I'm building here locally, executing on my local machine, there's a node modules directory. And that's the installation on my local laptop for those packages. But now, Node modules is compiled based on the operating system that you're using. So I'm using OS X, so Node modules is built based on my system. My Docker image, though, or my Docker container, is running off of some variant of Linux. In this case, I think I'm using Alpine Linux. And so the node modules from my OS X installation is not going to work in an Alpine Linux image. So that particular statement there is just overriding my local node modules so that my Alpine Linux distribution is not trying to run modules compiled for OS X. All right, that's out of the way. Next up, we've got our ports arguments, which was the -p from our command line. We're mapping port 3000 locally to port 3000 in the Docker container, and then also mapping port 9229, which is our debug port for Node.js. Environment, we're specifying some environment variables. And then we've got that entry point, which is an array of commands. So basically it's saying, hey, when you launch, run the command npm with the arguments run dev. So it's just the same as you sitting on a terminal prompt inside this container, typing npm run dev. So that's our Node.js application. But wait, there's more. Looking down at line 18, we've got a database known as DB. The image, so now look up above on the Express, we had our build section because we were building that Docker image from our own specifications. But here on line 19, we're saying from the database, just grab the standard published Postgres database. And now you've seen me use :latest for a lot of Docker images today. This time we're using :12.1. So we're saying from Postgres, grab the image that is tagged as 12.1, and that 12.1 happens to represent Postgres version 12.1 so that I know exactly what version of Postgres I'm installing. Container name, again, I'm going to give it a name that's something meaningful whenever I look at my running Docker containers. Setting some environment variables. In this case, Postgres allows you to set the default user and password and database through environment variables. Check out that password, by the way. That is some tight security, right? On that note, this is only running locally. I would never publish something like that. And we'll get into how to publish things like passwords in a future video. Next, though, we have our volumes. Again, a mounted volume. Now, in this particular instance, we're mounting a volume called app data, but it doesn't have a path, right? So that would not really be a path reflected on my local hard drive. And I'll show you where that comes from here in just a couple lines. But we've got our ports. The default Postgres port is 5432, so we're mapping that to port 5432 on my local workstation. Next, on line 30, we've got Elasticsearch. Again, just pulling the default Elasticsearch image, version 7.8.0, giving it the container name Elasticsearch, and another volume here mapped of Elasticsearch data that, again, does not look like any folder I have on my local hard drive. Then we've got the ports, which are our default Elasticsearch ports, 9200 and 9300. And then an environment variable setting the discovery type parameter for Elasticsearch, telling Elasticsearch that there's only a single node in this Elasticsearch cluster. So please don't waste time and fill up my logs looking for other nodes that don't exist. All right, now finally, we're down to this volume section where you'll see the app data and the Elasticsearch data that were referenced by the mounted volumes for our database and Elasticsearch. And both of these have driver statements that say local. So what that says is Docker Compose is going to create some file shares and mount those in there. And so that's going to be managed by Docker Compose. Now, because I'm running OS X, Docker actually runs inside of a virtual machine on my workstation. So we've got Docker running within a virtual machine, running within my OS X installation. And so those volumes are going to be created in the Docker system on that virtual machine. And that gives us data persistence, right? So whenever I write data to my database or when I write data to Elasticsearch, it's going to be written to the database instance, which is going to save that database query into the file system as Postgres does. And that file system is actually saved off using that volumes directory in my Docker Compose file, so that whenever I bring my Docker environment down and then later bring it back up, I haven't lost all of the data in my database or in Elasticsearch. So that's kind of how that works. Now, some of the other things worth pointing out here. These service names, right? We have Express on line 3, we have DB on line 18, and Elasticsearch on line 30. Those are significant because Docker Compose is going to set up networking for this environment. So from my application, my Express application defined in line 3, when I want to connect to the database, whenever I want to write or read data from my Postgres database, I don't have to know what the IP address of that database instance is. All I have to do is call a thing named database. Think of it as like a host name or like a DNS name. If you want to go to Google from your browser, you don't know what Google's IP address is. You type in google.com and that resolves to an IP address appropriate for you. Same thing is going to happen here. We've got this locally defined network managed by Docker Compose. So when I want to connect to the database instance, I just use DB and Docker Compose will translate that to the IP address for me. Same thing with Elasticsearch. I gave it the name of Elasticsearch. So when I want to read and write Elasticsearch data, I just use the name Elasticsearch and let Docker Compose networking handle figuring out who the hell that actually means. So great story, right? We've got a really cool looking YAML file, but what does it actually do? Well, let me show you how it works. All right, so I'm in my terminal in the directory that contains my Docker Compose file. So the magic happens with the Docker Compose command and the magic keyword up. That's going to bring everything up. So one of the cool things is you can see here on the left side of the screen, it's prefacing each log statement with the service name that generated that log entry. Kind of makes it a little bit nice, except for Elasticsearch, and it's always freaking complaining about something. But anyway, that should be up and running. So let's go over to our browser, and our endpoint is working. And all this one does is just says respond with a resource. So nothing, like super sexy or cool, but it does illustrate the point here. Whenever we're ready to bring it back down, we can just hit Control-C and it kills everything. And that's how you can use Docker Compose to bring environments up and down and implement some volume storage for persistence and some networking to make it easy to find the services and resources within your environment as well. All right, so now we know how to build complex environments, run them locally, build our images. And so we're kind of at the point where the next stage in this evolution would be to take the images that we've been working on here locally and get them somewhere where we can use them to launch our applications, whether that's in AWS or Google or Microsoft or our own data centers or whatever it is. We've got to get them off of our laptop here. And we do that through a process called pushing our images up to a Docker registry or a container registry. All right. So let me just show you what that looks like. Share my screen again. Already got the right thing shared. I'm in this folder that we started working in earlier. We've got a file called Dockerfile here. And now you've already seen me do the Docker build command, right? So we're going to do Docker build -t. Now this time, I'm going to push this up to a repository that's used by me personally. So I'm going to tag it as willbutton.nginx. And give it the dot to tell it look locally for the Docker file here. It built that. So now I'm going to do a Docker tag, and I'm going to tag that image I just built. So will button tagged nginx, and then I'm going to specify the path to my registry or my registry here. So this is my Docker registry here. It's going in the path for images will button. And now you see right here, it says latest. I'm going to just remove that and I'm going to tag it as nginx. So now basically all I did there is I added an additional tag to my Docker image. We built that image, tagged it as will button, built it as will button tagged with Nginx, and then I added an additional tag on top of that with the path to my Docker repository, which happens to live out in Amazon AWS. But it's still not out there, right? I just tagged it. I did not push it. So let's do that next. We're going to push. So use the Docker push command, and then I will just grab that right there, paste it in. And so now that's going to push it up to the repository, and you can actually see that happening right now. So that's doing its thing. And what that does is it takes this image that we built locally here that resided on my hard drive, pushes it up to a Docker repository in the cloud. So it's now available to anyone who can log into my Docker repository, which includes my CI/CD servers, which are responsible for deploying my applications. So whenever I deploy an application that uses this Docker image, my CI/CD server will download it from my Docker repository and run it as a container. All right, so we've done a ton of stuff in this video, like a lot of stuff. And I want to show you what my system actually looks like right now. So let's clear this out and let's do a Docker images. And holy shit, look at that. Let's do a Docker PS. Okay, there's some stuff running there. That's all Kubernetes related stuff. And let's do a Docker PS-A, which I don't think I've shown you this one before, but this one actually shows you containers that have exited as well. And look at that. There's a ton of stuff there. So that's a lot of garbage, right? It looks like a homeless guy lives inside of my Docker system right now and just isn't cleaning anything up. And that's going to lead to performance problems over time, not necessarily for my Docker containers, but for me personally when I start running out of disk space. So let's take care of that. And to do that, we're going to use the Docker system prune command --all. And I think we want a -v in there. We'll see if that's right. No, -v is not right. So just --all. Actually, oh, let me just show you something else here. Let's just do help. Does that work? No, it's --volumes. All right, always with the double dashes. So Docker system prune --all --volumes. And now what this is going to do is it's going to clean up everything that's stopped and not running in my Docker system. So any containers that have exited, it's going to remove those. Any Docker images that are no longer being used by anything, it's going to remove those. Any of the volumes, if you remember back to the Docker Compose section, we could create persistent volumes. Any of those that have been created that aren't in use are going to be removed as well. So let's just tell it yes here and enter, and it's going to go through and do its thing. This is a good thing to run locally on your workstation periodically. If you manage servers that run Docker containers, you're going to want to set up a cron job that runs this daily. All right. So every single day it runs through and it cleans everything up, because you're going to have new deployments are going to create purge Dockerfiles. You know, they'll create exited Docker containers. Containers can crash that will still be lingering around. Images will be superseded by new versions. There's all these things that just creates old data in your Docker system. And you want to clean that up proactively rather than waiting for your server to get clogged up and then crash, because then when your server crashes, it takes down all of the containers, and that leads to outages. Outage leads to your boss calling you. Your boss calling you leads to an ass chewing. An ass chewing leads to you getting pissed off. And, you know, it's just a vicious cycle that we can circumvent completely by just running this command in a cron job daily. One tip though, when you do schedule it as a cron job to run daily, make sure you include the -y flag. -F. Include the -F flag to force it. Otherwise, it's going to run this command and wait for you to press the little Y key on the keyboard, which you're not going to because you're at home sleeping because you scheduled it to run in the middle of the night. All right? Okay, so there we go. That finished up. Finally cleaned up and reclaimed 23 gigabytes of space. And just to confirm back here, yeah, it is the -F or -- force flag that will prevent it from prompting for confirmation whenever you run that command as a cron job on your own servers. So that's Docker. That's containers in a nutshell. And obviously there's a ton of more info in there that we can go into, but just looking at the raw footage here, I'm well over an hour. We'll see what this comes down to when we're done editing it. And if you stuck with me this long, if you're still watching this, thank you for watching this. Honestly, thank you. I mean, hell, I don't like spending this much time with me, but for you to do it, I really appreciate that, man. And yeah, so we'll get this published out. Let me know your thoughts on it. Be sure and jump over in the Discord if you want to chat about this or other DevOps topics. And I'll see y'all in the next video. Now, in addition,
So what?
Another command that's really handy is Docker PS and Docker. Oops, no, it won't. Oops, wrong window. Why do you gotta look like shit like that, dude? Why do you gotta look like that? That's the wrong one. There it is. There it is. And so all of that's good, right? All of that means that we're running as a non-root.
What the hell were you going to say?
Actually, hang on a minute here. Yeah, making sure that's actually a -V because I've screwed that up a couple times already. Now, this time, what am I doing this time?
Right. So